Hi, and welcome to another old steam powered machine shop from the Florida Hideout in lovely Englewood, Florida. Got a governor here that I started rebuilding last winter and I didn't get it finished. So I'm going to continue on with that. It's a Pickering governor. I got the top part done, new leaf springs put in it, and re-leaded. And now I'm working on the gearing and the main shaft of it. But before we get into that, I want to tell you about the Florida Flywheelers Antique Tractor Show and Flea Market in Avon Park, Florida, coming up in a couple weeks. Myself, Adam Booth, Keith Rucker, Jim Bollinger of Do Right Fabrication, and maybe a couple other YouTube creators are going to be there on February 19th. That's Wednesday. That's the opening day of the show at the Flywheelers Machine Shop. It's not in the historic village. That's their actual machine shop building. It's pretty big. And we're going to have a meet and greet there from 2 in the afternoon on. And I'd like to see you there if you're in the area. It's a great show. You'll enjoy it. So, to get to the governor, we built a Pickering about this same size but newer version. It was 3 years ago, and if you wanted to go back and check on that, that would be video number 20. This one I started last year, and that was video number 52. Got the top part finished here, new leaf springs put in, and lead poured back in. So this is all set to go. So now I'm starting on the valve and the gearing and the mainframe. I got it set up in the vise over here, and gonna pour the Babbitt on the main shaft. So I'll get going on that. Okay, here's the setup with this. I ran the Babbitt out of here with a torch, and it just left a cored rough cast hole a little bigger than the shaft, so there was room for some Babbitt in there. And the factory had cored this so that the holes were actually small at the end, so they could machine them in some kind of a jig to get the positioning of the shaft right with the bevel gear and everything. So I wanted to get the shaft hung in there straight, so I made a couple of wooden plugs on the end that just went in that and centered up on it, and then the holes were bored for a real tight fit on this. I can just barely squeeze them in there all the way up to here, and then I just have a wooden wedge here to hold it up tight against there. These edges here are pretty smooth, so I'm pretty sure it won't leak any Babbitt out of there. And I just wired a little clamp arrangement on here just to make extra sure it was up tight. So I'm going to warm this all up with the torch and the shaft, warm the shaft up. Then I'm going to put some lube on the shaft, put it in there, and pour the Babbitt through this hole, which also serves to key the Babbitt and actually mechanically lock it in there. I don't think it would be necessary in that respect, but pour it in this hole, and that leaves the oil hole for air to come out. So we'll see how it goes. I've been heating this carefully for a while. This is actually the second pour. The first one didn't fill out all the way in the top because I didn't have it hot enough. It's kind of hard to control the heat with a map torch when you got to heat the Babbitt in the ladle and heat the shaft and heat the housing and put the whole thing together. So I tried it a little different way. I put this housing in a toaster oven and heated it up to about 450. So Babbitt melts about 650, so that gives it a little extra time to flow in there. The other problem is this is quite long and quite narrow and it pulls the heat out fairly fast. So that's a little bit of a problem. And the other thing is the Babbitt that I'm using is actually reclaimed from our old railroad car, and the railroad used a lot of lead in their Babbitt because it was cheap, and it's not as good as regular high-speed Babbitt that you buy these days, but it's plenty fine for this. And I don't think that lead-based Babbitt is fluid. You got to heat the heck out of it to get it to flow nice. But I think I got it now. I'm going to take it apart and see what it looks like through the bore. When that Babbitt cools down, it shrinks, tightens up on the shaft. Oh yeah. That should be fine. Okay, now I'm going to run a 1/2-inch reamer in here to give it a little clearance. I'm using WD-40. Mineral spirits is actually better, but This is what I got here. Polish up the shaft a little bit, see how it fits. By the way, if you got a little indicator or a micrometer or anything you need repair work done on, this is the guy right here. Mark Ratkowski, Mr. Tool Repair. He's on the internet. He's done a couple indicators for me and it's done a spectacular job, very reasonably priced and incredibly fast turnaround. We'll check the fit. No play at all, but it slides nice. That should be just about right after it runs a little bit. One thing I forgot to tell you, I drilled a second hole here to pour through so that to make sure it would fill the back side, because it's pretty hard to get the Babbitt to go all the way up into this narrow cavity. Now this is just to show you what you can do on one of these little lathes if you don't have a milling machine. This is a Atlas, and they have some pins down in these holes, so you don't want to lose them out of there. And I'm short one set screw, so I borrowed one out of the cross slide out of the compound. Okay, now we gotta set this up so that it is square with the spindle, sort of like tramming in a milling machine. I'll get set up and show you. Okay, so we're straight that way. Tighten these up. Okay, the idea is to cut a flat like the old shaft had for the set screw, and I've got an end mill set up in the chuck, and we'll just take a few cuts off of there until the width is right. That should work. Next thing, I'd like to clean up this pulley a little bit. It's been repaired, and I'm sure it's going to be very hard through here because it looks like it was arc welded with something. So I'm just going to clean up the edges and smooth it up, see how true it runs. Made a arbor out of leftover piece of the shaft. Center drilled it over here and lined it up, so we'll see what we got here. Slow it down a little bit. Oh, it runs pretty true. Next problem is the top shaft. And believe me, I had a heck of a time figuring out how this came out of there. I thought it was pressed in, but as it turns out, back in 1906, the way they did it was they turned this whole thing to diameter, left this oversize, and then turned a taper on here that fits into a taper there. It's down into a taper really nice, and then they swedged the end of it where it came through the hole just a little bit to hold it. Well, the other amazing thing is, what is this taper? It's exactly the same as a Morris taper, number 2. Well, you stop to think of it, why not? They had them. Morris taper holds real well. So, in the meantime, I got this piece of 5/8 stock that's hollow stock. You can buy this. Saves a lot of time if you have to have a shaft with a hole all the way through. The only problem is it's 5/8 and it almost drops through. Other thing to do is you take a solid piece of 3/4 and turn it the whole length, which would be a lot of work. Then you got to drill it the whole length, which would be a lot of messing around. So I thought what I'd try to do is weld this up on the end, weld stringer beads along here to build this up. It doesn't take much. It's just got to be about maybe 40-50 thousandths bigger on this end of the taper when we get done with it. And don't have a taper attachment on the little Atlas lathe, but I think I can do it with a compound. So that's the plan. Here I'm just cleaning up the 60-degree angle on this hole so I can put the center in. Got the compound set to 60 degrees. In order to set the compound up for the taper, I put this is just an adapter, a 1 to 2 Morse taper adapter in there. And I've got my indicator set on center. And I've tapped this thing around and played with it until I've got it pretty steady, moving it back and forth as steady as I'm going to get it on this lathe. So this angle now is set to the Morse taper, which is exactly the same as on the base of the governor, and I'll put the piece back in there and cut the taper. Good idea to lock the towel. Well, as you can see, this end of this is pretty well torn up where I beat on it to get it out of there, but I believe that this first part here, and I turned this straight for about 1/4 of an inch where it will extend beyond the hole in the housing. I think this was drilled out to make the wall thickness here thinner for about 1/4 of an inch so that this would swedge out easier. So I'm gonna run a couple of drills in here and drill this out a little bit to make the wall thinner. Okay, here's the finished shaft and the configuration of it, and the taper fits in there just really nice. That's going to drive down in there really tight, and I'm going to have enough of it sticking out here to swedge down against the chamfer up in there. If you can see it. The OD here turned out to be exactly 1.5 inches, 1/1000 oversized. And I thought it would go in here because I figured this would be worn some, and it's not. It just starts in there. But I think rather than trying to cut this down 2/1000, I'm going to fit the governor to the shaft, and to do that I need an adjustable 5/8 reamer, which I got to hunt up somewhere. So that's about all I can do for today. Hope you enjoyed seeing how this governor is going together, and appreciate all the subscriptions and the comments. We'll talk to you next time.